Thanks very much. It's very generous of you to associate the last spot with something nice when I realize I'm standing between you and drinks, but not to fear. This talk is an enterprise talk, so I'm pitching it, or at least I pitched the talk, under the impression that you folks would be kind of enterprise level people, either A, interested in what another enterprise level company is doing, or B, perhaps you're looking to move your own company into the cloud, and you're wondering like what our own experiences were. But however, talking with a lot of you today and listening to some of the other talks, most of you are probably pretty technical. So the disclaimer is this: I'm gonna stay up a little high, but I'm not afraid to go drill down really hard, so I'll try to go fast and get to questions as soon as possible. And that's kind of the part of this discussion that I like better anyway. So let's begin. So, okay, so let's remember, we're in this context of you're an enterprise person interested in moving to the cloud or something along those lines. So you have a problem, and the problem that you've been asked to solve is you need to move your infrastructure from your company from an on-prem data center or just generally some box in your building into the cloud. Or, alternatively, you've just been hired and you've gotten to a situation where maybe you have some data on-prem and you also have some stuff in the cloud, but you've noticed that the data lake that you've been promised in your interview is actually a data swamp and is almost impenetrable. This is the problem. So you take stock of what you can find amongst all of the various data sources in your company, and you find that, well, there's some things that are pretty standardized across industries, especially if you're a tech company dealing with a website or an app, right? So you know about logins, you can store those, you can store impressions, those are fairly common. Clicks, purchases, these kinds of things are fairly abstract, and so we understand kind of how to deal with them and what sort of data structures we can put them in. And that's all well and good. But then you realize that you're working for a tech company and Java rules the day, and so there's hundreds and hundreds of microservices within your product, and each microservice has its own log, and occasionally a log from that microservice is actually of interest to you for either debugging or for some other kind of process. This is definitely something that has happened to us. And then you realize that every single line of business has its own abstract structure. So for example, right, so I work for Expedia, and we are like the world's like most integrative online travel agency. So not only can we get you hotels, but we can also get you flights, we can also get you cruises, we can also get you cars, we can also get you things to do, amongst many other types of things across a variety of brands. So as you might imagine, for us, every single line of business is totally different. For example, flights. Oh, here, how about some industry, kind of like industry trivia for you, right? So like, you're familiar probably with one-way flights and round-trip flights, but do you know that sometimes you might want to fly from LAX to JFK and go back to Burbank, right? Say for whatever reason, that would be in industry parlance an open jaw type of flight. So those types of data structures are a lot different than, say, a simple hotel, which is just fixed at one point in space, and so you're just kind of worried about check-in and check-out. So yeah, every line of business that you might deal with has its own abstract type of data structure. And based on all of this kind of junk that you have to deal with from various engineering groups and various sources within your own company, you want to actually A/B test things that you're trying to build. So you've got to basically duplicate, or at least double or triple everything that you've been working on. So it's a mess, inherently. And so you've been asked with, in other words, if I can reframe the problem, can you please turn all of this massive amount of data into some cash, right, using some buzzwords, some big junk things here, especially Spark, which is, I guess, the reason why we're all here today. So that's the task. So I'm going to kind of walk you through a little bit of my own personal experience and our company's experience, or at least my team's experience, working through this particular process, and I'm going to organize it as follows. First, I'm going to give you some context and disclaimer, a little bit more about how to interpret what I'm about to tell you. Second, I'm going to give you kind of a lightning review of data platforms to also kind of set the story up a little bit, to give you a little bit more context again. And the real meat, I'd say, of this talk, the real interesting bits, the real prescriptive bits, if you like, will be at this third kind of piece, where I'm just going to throw out to you our experiences rehashed as organizing principles, things that I recommend you to follow, or at least consider in designing your systems. Okay, so context and disclaimer. So I'm an academic by trade. Worse, I'm a theoretical physicist, not a computer scientist. So what that means for us is that we're gonna have different words for the same thing. So once again, please feel free to raise your hand and scream if what I'm saying doesn't make sense. And when you ask me a question, I might not understand, but we have the same words for the same, we have different words for the same thing. Also, are there any economists in the house? No. So on the grand scheme of people who think they can solve every problem in the world, there's the physicist. I know there's physicists in the house, I see one. And then there's economists, and then everyone else seems to follow in between. Anyway, here at Expedia, we have work still left to do, so this is kind of an unfinished product. We're still working on it. So I'm implicitly assuming, well, I'm assuming that you're gonna take what I have to say, these recommendations, with a grain of salt. That is to say, I'm just one of an ensemble of people that you're probably speaking to today. So by no means am I assuming that I'm correct completely. Okay, where are we? Good, so a lightning review of data platforms. Supercomputers. When I was in graduate school, we had access to supercomputers, these very fancy things that you had to, if you were really fancy, you would code up an MPI or something like that, but there would eventually be some homework assignment that you would have to have some professor pay somebody to access a few selected compute hours, or at least some bandwidth at some supercomputing center at some other university far, far away. Usually, for my case, it was at the University of Texas. And typically, since you were a low priority graduate student, you'd be stuck submitting your jobs at like 2:30 in the morning just to get any kind of leeway on that, which was no fun at all. So surprise, you come to a corporate environment. I get hired at Expedia, and I was amazed to discover that we have, not only do we have our own supercomputing center, essentially we have our own data center. We have multiple data centers. So we have all of this computing power that we just devoted to our team. At least that's how it started, right? So the data science org started out. We had played around with Hadoop and putting our data out there, and that was great until more and more users wanted in on as our data set started growing and growing and growing, and more users wanted in. We quickly discovered that the queues came back, right? And oftentimes you've got business intelligence folks writing SQL scripts, and they're throwing entire table scans over an entire table, slowing down the entire, slowing down everyone's jobs. In case anyone needs any convincing whatsoever, the beautiful thing about the cloud, right? So this is the obligatory you should be on the cloud slide, which tells you that why it's important is because if you have very task-specific jobs, you can set up hardware specifically for those jobs, and you can scale it up and scale it down. I don't think, based on conversations with folks, that I really have to get into this too much, but there's a few things that are probably worth talking about, and that is this kind of real-time, well, anyway, I feel like I don't have to convince you folks of any of this. So I can just get right down to the heart of the matter. And that is what I'm going to say. So based on our experiences, these are kind of like the organizing principles, the kind of recommendations based on our own experience and troubles with moving a lot of our kind of productionalized machine learning infrastructure into the cloud. So if you like the idiosyncratic operating principle number 1, or IOP1, is data clarity. Tagline, big data, big noise, right? So imagine, if you will, that you run a website, and every interaction that a customer user has with that website gets logged. You probably are going to use that information for something. Lord knows we do at Expedia. So what would that mean? So again, clicks, impressions, what did the user see? What did the user purchase? So for the particular case of, say, rental cars, we're interested in what the user saw. So you look at, we get this great impression set of every single car the user saw, and it's this horrendous, beautifully horrendous nested JSON file, right? And within the schema for this particular row of car rental impression, you have something for this particular, the rental car presented at position 3, there's a geographic entity associated to it, and maybe that geographic entity is where the user is going to obsessively pick the car up. and maybe that pickup location has some latitude and longitude, and maybe it's associated to a specific brand and all this kind of junk, right? All of this information. So there's hundreds and hundreds of fields of this crazy nested JSON that you need to extract out. And if one of those fields is broken, who do you ask to fix it? Who do you even ask to verify that the data itself is any good, right? Especially if this row is just one item in one massive data set of every single interaction that had come onto the website at any given point in time, right? So where is the data that you're looking for? Who owns that field? Who owns any of this field? What even, so, right, so then there's this other thing, right, where I guess before I joined industry, people were using a lot of Microsoft kind of SQL Server database type things where the field names had to be restricted to a certain size. And so everyone went through this whole process of deleting vowels from field names. In terms of clarity, that's another thing that you should never do, right? Let the field names be human readable so that people can really understand what these fields are. Anyway, so yeah, and sometimes you might discover, like over the course of time, if you're just data streaming in, sometimes fields disappear. So again, it's this whole issue of like, who owns the data? Why is this field null? Why is this field null now? Another big important issue is even though it's supposed that, you know, the names of the field are fine, imagine a situation where you have a field, say, called hopscotch session ID. Say that's just some word that you're interested in. The question is, hopscotch, is that one word or two words? It really matters if your fields are case sensitive and you're using camel case, right? If one case, if they're null, because so all of these like tiny little minutia data problems that will like definitely slow you down. So I guess the general recommendation is publish descriptive things about your data set internally. Know where each field belongs. Who can I hold accountable for the data being missing? Data clarity is really, really, really important. Okay, kind of in line with that is, like, what does your data look like? How is it being stored? How is it being dropped? Right, so here's one of the big problems that we ran into, is particularly, especially with this rental car data set, right? So maybe you've got some data that's streamed into S3 some way, and maybe it's gzipped, and maybe the files are really, really tiny because they just are, whatever got dumped that minute gets dumped into a file, and maybe it's really awesome if you're doing some kind of streaming analysis. But if you're trying to do some kind of, you know, offline training supervised learning model where you need to deal with months or years worth of data at the same time, and you want to load all this data into Spark because you're dealing with this crazy nested JSON data set, it's a terrible situation to have all these tiny little files. Really what you want to do is you want to have kind of large-sized files, and you want them to be in a nice Spark-friendly format, right? Or at least if that's the tools that we're using, that's the tools that we're using. And you want the compression algorithm to be such that it kind of respects the partition. So a big thanks to Jason over there in the corner for a lot of the help that he had with just slapping us across the head, you know, hey, what are you guys doing? Fix this. Giving us like these really obvious kind of tips and tuning recommendations for dealing with Spark. Big help from Databricks there. And also like another guy on our team, Charles Pritchard, who has done a lot of work cleaning up our data set too. This fellow here invented the field of data. He calls himself a data janitor. So it's good to have somebody on your team who can clean things up. Okay, clarity, really important. 2, engineers are not data scientists. Why would you need to do that? So here's one thing that was really surprising to discover is that so we moved out to the cloud and we got a lot of space set up, we've got a lot of processes set up, we had a lot of things, and then at some point, you know, the engineers, we started spinning up a lot of clusters, and the engineers got mad because they were spending a lot of money, and so they kind of put some formalized structure on things. And once they put some formalized structure on things, they were fine to like host an ETL table and load and sync things from our on-prem data center and put a whole bunch of Hive tables up in the cloud, and that was awesome. But one thing they forgot is that data scientists need to work on data sets and algorithms and test things out, and they left us without any scratch space to start out. Huh, right? Yeah. So make sure that you communicate your needs if you're a data science org to the engineers who are helping you out. You know, other things that are also important that were huge roadblocks for us that still kind of run into in terms of friction, in terms of getting things started, access issues. You really need to make sure that your people have access to the data that you want. You're trying to break down those silos, and it's really awesome. And of course, it creates this huge mess. But if you can see the data table, if you can see the S3 bucket, but you can't copy the files or you can't get at the data, it's really frustrating. Another thing that you might want to be able to do is give your data scientists kind of access to cluster bootstraps, because maybe they're testing out new algorithms. Right? Maybe they don't know 100%, and they don't have time to set up a JIRA ticket to ask for another cluster instance image to be set up so that they can launch it. And maybe that takes 3 weeks, or maybe it takes 2 days, but it's still too long. Right? Other things, we probably need sandbox clusters. We need something to play around with tools. So we need the ability to spin up clusters and design them on our own. Maybe small ones, you can restrict us, that's fine. We don't need ginormous ones, but we need to play around. We need to test. And here was another big one that surprised me, how problematic this was. We might need to share notebooks across accounts. So at Expedia, and I don't know how many enterprise level people are out here, have multiple brands, right? But Expedia, we share our work, and we own a lot of other companies, and one of them is HomeAway, which is like VRBO. It's one of these vacation rental companies. And they're not on the same, say, AWS account as us, but they have a similar sort of problem, right? They need to rank hotels, or they need to rank rooms. And so maybe they're really interested in sharing work, right? So it would be really awesome if we could do that. But it turns out, so the Databricks platform, a lot of platforms have this ability where you can sync your notebooks through GitHub, which is really, really helpful. So keep that in mind. Of course, there's all kinds of logistics to be able to do that, permissions and stuff like that. So make sure that you can facilitate that for them. And finally, like, once again, along the terms of engineers are not data scientists, data scientists don't speak IAM role. And if they do, awesome, that's great, but most of them don't. Thank you. Yeah, you guys are all photoing, yeah, right? We don't speak that. So for example, if you say, oh, hey, we need access, we need a cluster that has access to these buckets, don't give us a form to fill out that's a bunch of, what, JSON? I don't know what the hell that thing's in. We don't know how to do that. Don't ask us to fill it and tell us that you'll look at it. Set something up for us, or give us access, one of the two. Okay, so so Stitch Fix talked earlier today, right? And so they're the ones that wrote that great article, right? Engineers should not be writing ETLs. So I'll defer you to that article for that. But so write your own pipelines as a data scientist, but. And this was a hard-fought lesson for me. You need to explain what data science is to engineers. So that field that I talked about, that little that GPS location of that one random kind of pickup location for rental cars, it seems so trivial to some engineers, like, oh God, why do I have to put that in there? And then when you can tell them that, hey, look, if we put that in there, we can build a better model. If we build a better model, we can get 2 million annualized gross profit lift. $2 million is on the table, and you're messing it up, right? So you explain to them that it's actually worth their time to fix the data, right? But you have to explain that to them, and you have to explain that to the other stakeholders. Speaking of other stakeholders, PMs are not data scientists. So the tagline I seem to run into a lot is, you don't need that, right? So PMs could be product managers, they could be process managers, they could be program managers, project managers, whatever kind of managers. So let me just tell you like a little story that I ran into, right? A little micro story. So once upon a time, we were trying to consider possibly making a model for sorting flights, because that's what we do at Expedia, because we sort things. And why do we sort things? And it'd be a great talk by Matt Fryer tomorrow morning about why sorting is worth lots of money, or at least partially. But we sort things. So once upon a time in the flight data lake, they decided they were only going to store 10% of the search impressions. So what that means is, right, so flights go in and they go out typically, so round trips, inbound, outbound. So maybe you see, as a user, you'll see like 20 inbound, and maybe there's 20 outbound, so what's 20 times 20? It's like 400, right? But in reality, we have like a lot more than that, so maybe there's like a total of 1,600 combinations that you can imagine presenting to a user. But for whatever reason, when they set up this, even though it was on S3, they were only storing 10% of the search impressions. Why do they? Well, because they got it stuck in their head. The product manager got it stuck in his head that we don't need that much data. It was wasteful. But they still asked us to build a sort model. And so worse, it was the cheapest 10% of right? Now, some of you see where this is going, right? So this is the cheapest 10% of the search impressions that were recorded. So of the things that we were supposed to be able to sort, we only got 10% of them, and the 10% was the cheapest. And even worse than that, the items which customers booked were not even in that list of things that were given. So what does that tell us? So basic statistics. I like the Socratic method, but like, I'll spare you. I know it's late. So what that means is the model is going to inherently be biased towards cheaper flight. So, and we already were using a price-based sort to begin with, and we only were given the cheapest 10%, so of course it was going to still be a price sort model. So it was, in other words, after diving into this terrible data lake and figuring all this out and trying to build a model, we discovered, oh, there's nothing we can do, right? Humongous, humongous frustrating failure, largely because the data wasn't stored correctly, right? So talk to your TPMs, talk to your PMs, talk to them, make sure they're on board. You need to communicate. We need the data. You got to feed the algorithms, right? Okay, good. So finally, and I get a lot of flack for this. I'll try to speed it up a little bit. This isn't finally. Data scientists are not engineers. Any engineers in the house? A few, right? Yeah. So you can slap us back, and please do. So I'll be quick about this. Like, you need to support models in what format in production? Like, so, right, we've got people. So pick a robust standard and stick to it. Please, like we use JPML. Maybe that's not for you, but that's fine, but pick one. If you're gonna use PMML, awesome, but don't try to support scikit-learn models on top of that or H2O models on top of that. Like, just pick one and stick with it. If you're big enough to have this concern about picking a standard and productionalizing and all that kind of stuff, you're big enough to commit changes to the code and if it's an open source project like JPML, like we did with matrix factorization, or at least it's in the pipe. Not sure. Anyway, some other fun things that might be important is data scientists. I don't know about you folks, but I'm from academia. There's a lot of them from academia. Not all of them are like hip to stuff. Everybody should use Git. Use it now. Right? I can't believe I have to say that. Production code matters. Blah 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 blah. Pipelines count as production code. Blah 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 blah. Be clear about things. Comment. For the love of God. Put comments in your code and share it. Okay, anyway, so here's the fun part, right? Like, okay, so close the data loop. That's the product person in me. Close the data loop. What is your data doing? Do you have big data? Awesome. Set up a supervised learning problem. That's right. This is fine. You have new data? Consider some bandits. Multi-arm bandits, contextual bandits. You can do a lot of new stuff, especially set up your priors appropriately, whatever. But the point is, and this is something that was lost on me until somewhat recently, I'm sure there's a lot of tech folk. It's cool if you're running like a construction company, that's awesome. But I'm sure there's a lot of just website people here. And this seems to be like something that, like I said, was lost on me. Is you really want to empower your systems by design. So I'm going to leave this part and move into kind of the discussion based on this, right? So empowered by design, what does that mean? You have a website. The way the user experiences the website is under your control. Maybe not you personally, but your company or institution, right? So the causal link between them getting onto the site, to moving through the site, to clicking on things, to looking at stuff, to purchasing things, to going back and purchasing other things, all of that you control, right? It's like a video game. Every single move that the user can make is under your command. So at Expedia, for example, you can't book a hotel unless you first click and view the info site page. You can't get from the search results page to it. There's no one shop, there's no one click to that. That was a choice that we made. Amazon, that's not the same case. I'll leave you with a big idea and then take questions. So the big idea is this. There's a series of blog posts by this guy, Adam Kelleher, principal data scientist at BuzzFeed, and he's looking into something called causal data science, causal inference. I know it's not like too super hip, especially with economists and statisticians, and that sort of thing. But one thing to keep in mind is there it's kind of based a lot on the logical, you kind of convert the logical system of causal relationships between items as a graph. But as a website, this graph is under your control. You're building it implicitly by building how your website works. So in some sense, if you want to control users' behavior, if you want to guide and direct, enforce discover, whatever, all of that kind of stuff. You can do that not just by dumping a whole bunch of junk into a machine learning algorithm, turning the crank and see what comes out, right? But you can also do that by constructing your system in an intelligent way. Thank you.
All right, we open up the floor for questions. Anyone want to take the first step?
General question, how do you convince data scientists to care about engineering practices, like using Git or formatting code?
So that's a good question. So on the one way, you could make it to be a standard, right? So you feed it back to them and says, no, it's not done yet until there's that's the way it was done with me. Another way that you can do that is by incentivizing it, and one way to incentivize it is to set up an internal repository. So as soon as people are looking at each other's code, right, then you should be doing peer review anyway, but if you're going to put it on an internal, and it's like some sort of internal enterprise GitHub type thing, and you're forcing people to look at it and having some review of it, that helps. Shaming helps, right? Ask them to present their code at a team meeting. That might be another way. And also making them responsible for the ETLs, especially if it breaks, that could help.
Hi, Sean. Very nice presentation. I'm as a fellow data scientist, as also, I mean, it was very interesting to hear your impressions about that. My question is, how would you communicate to data engineers importance of some data science techniques? The issue that I tend to run into very frequently is that data engineers tend to optimize things that they shouldn't optimize in. For example, I design a randomized experiment, and they see, oh, the control group doesn't need to get anything. Let me select the control group a bit later after the treatment group. And that messes up the whole experiment, because now they're a bit different because of something that wasn't accounted for. And like, there's little important issues that kind of we care about a lot, right, in the causal inference, which data engineers tend to optimize away, kind of like, oh, let's do this a little bit later or something, which tends to mess up analysis. And this is the kinds of issues, let's say, I personally tend to run a lot into.
Yeah, that's a really good point. So this was not the main thrust of that article that I mentioned about engineers should not be designing ETLs, but that's one reason why you want to, is because like another example where things get messed up is if the engineers are going to start like clean your data set for you, like, and you're not aware of what cleaning went on, that could be really problematic. So your best bet there is you need to yell at somebody. You need to yell and scream and say, hey, look, this data is wrong. You know what I mean? Like, so I understand that there's some hierarchical issues there, but that's bad practice from like the top that needs to be dealt with, for sure. You know, aside from that, you could try to quantify the errors and present them with, hey, look, so presumably there could be some interactions with some other tests or some other problem. We ran into something really similar to that, where they were going to present a new sort, right, the special sort that was specifically for us. But in order to do that, for whatever reason, they decided they were going to introduce a new tab onto the website specifically, which is like, what are you doing? You're breaking the scientific protocol. So ultimately, what does it mean for you? It means that there's noise. Right? And so if you can do your best to kind of quantify that noise, which I realize is not really easy, you can say, hey, look, this noise is causing our model to do this, and that's costing money. Ultimately, I think that's really the only thing you can do. But yeah, a culture of learning about machine learning is important. Reach out to them. Reach out. We have a product the product team has like a school that they attend like every once in a while, and they asked us to have data scientists go and give them talks, and make sure that you do that, because I know it sucks, but it's important.
A question here, Jika Chong from Acorns. We're hiring data scientists, and when you talk about these properties of a good data scientist, is there specific interview questions you ask?
Oh, man.
You can evaluate?
This is such a hard question. Okay, yeah, so this is totally idiosyncratic, right? So I can give you my answer. Like, what I do is the first thing, like a first pass, like a first thing, can you grep through a file? I just ask you, like, how would you collect phone numbers from some random text file? So as soon as I know that they can use a command line, awesome, that puts them in one bucket versus the other. And then, like, honestly, like listening to radio interviewers and asking how people ask questions, like another, what's like a good one is to make sure that you like ask them to describe a really concrete problem that they had to solve, presumably using data. Like if you can get, because if they really worked really hard on something, which most people who went through a PhD program understand completely, then they're able to tell you about the nightmare that they went through and how they serendipitously found the solution and how they worked for it. Like if you work that hard, and therefore if you're worthy, you know, probably being a scientist for this type of job, they should be able to communicate that to you.
Any other questions? All right, if no other questions, let's thank the speaker.
Thanks, guys.
Yeah.